Good day. You have these notes that you should have copied out from the previous video about isomers. And what we are going to look at is we're going to look at the isomers of hexane. And hexane is C6H14. That's what that mumbo jumbo was about. Iso, that prefix iso, means the same. So what's the same about all these isomers we're going to do? They're going to have the same molecular formula. But carbon can bond in different ways and create different kinds of chains. And that's what we're going to show you right now on a couple of pieces of paper. Good luck. I'm going to try to print neatly. Well, when you're asked an isomer question, and we are looking at C6H14, the first isomer I'm going to make happens to be hexane. Now, you don't have to worry about the name. Naming is something we teach next year. But hex means 6. So that means my longest chain of carbon atoms is going to have 6 carbon atoms. And then what I remember is I've got to have 4 bonds around every carbon atom. And let's make sure that fits on the, you can actually see what I'm doing. Alright, now each of these bonds is to a hydrogen. So those are all supposed to be capital H's. I've really worked on my calligraphy. So there's one isomer done, hexane. Now next isomer I'm going to draw and then I'll name it just so you can see it has a different name. And what happens is I've got to take off an end carbon and I've got to put it on somewhere on the chain that's not the end. If I put it back on the end, I'll be back where I started, and you'll see that in the next video. So now I'm going to put 5 carbons in my longest chain. 1, 2, 3, 4, 5. So I have 5 carbons. And for some reason I started doing hydrogens, but that's not really a smart thing to do. Better start thinking. And I'm going to put a carbon. This carbon goes on the second carbon of the chain. It can't go on the end or I'm back to this thing. And now I load in all my hydrogens. And if you count, you get 14 hydrogens there. Well, just to give you a name, this is 5 carbons in a row, so that's going to be a pentane, and it has what's called a methyl group. So this is going to be something called 2-methyl pentane. Pentane for that. CH3 turns out to be called a methyl group, and the 2 means it was on the second carbon. Well, some of you look at this and say, whoa, I can just slide this along. I'll swap these things. I'll make a new isomer. And you would be right. So I put in 5 carbons again. I'm just making a nice skeleton, but now this C that was here on the second carbon is now on the third carbon. Then I go crazy with this pen. Too bad it's not fine tipped. And Yahoo, 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 and Yahoo. And I say, you know, this is going to be a close cousin of 2-methyl pentane. I still have pentane. But now the methyl group's on the third carbon. So this is called 3-methyl pentane. So that's an example so far of 3 isomers of hexane. So we need to get some more. Oh, I better come back here for a second. Now some of you say, well, what happens if I just move this along one more? Wouldn't that be 4-methyl pentane? And nope, we'd actually be back to 2-methyl pentane, because if it would be from the second carbon from the end. We'd end up with the same structure. That's called mumbo and jumbo. Alright, so now we're still looking at C6H14. We're done with 5 carbons as our longest chain. So now we put in 4 carbons. 4 carbon chain. And what I can do is I can put a C up and a C down. And boom, boom, boom. Some of you are going to run to a store and buy a hydrogen stamp so you don't have to write all these crazy H's. So H's, remember, always go on the outside. That's why we spent time on Lewis structures. And if we tally them all up, I know that's pretty bad there. That is now 14 hydrogens. We need a name for it. 4 in a row. Hey, that's butane. Then I have a methyl and a methyl. They're both hanging off the second carbon. So this is called 2,2-dimethyl butane. That's all one name for something. Great name for a kit. Our next isomer can have 4 carbons in a row. So we do that. And this time, we'll have a carbon off, a methyl group off this second carbon, and we'll go 1 carbon over, and we'll stick it down here just because it gives us more room to put in all our slimy hydrogens. And now we go on a hydrogen feeding frenzy. And we go boom, 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 and boom. So there's our 6 carbons, there's our CH3, and if we add them all up, we get our 14 hydrogens. We have to have 14 hydrogens because we have to have this same molecular formula. This is butane. Now we look where the methyl groups are. Hey, we got a 2-methyl there, but now we have a 3-methyl. It's on the 3rd carbon. Doesn't matter which way we count. So we go 2, 3, di, because we have 2 of them. Di means 2. It's not a threat in someone's life. So we go 2, 3, dash, dimethyl butane. And you now have the 5 isomers, 2 here and 3 here for hexane. If we tried to shorten down to a 3 carbons in our longest chain, it turns out, nope, we'd end up getting back to one of our previous structures. On the next video, I use a molecular model kit to show you some of those isomers of hexane, and seeing that we always have to break at least 1 bond and form at least 1 bond to go from one isomer to another.